All right, hello everyone. So, I'm Charlie. I work with Bino Space Program like everyone else here. Well, everyone wearing a blue polo. And I am an engineer. But I'm also a student, so I'm not really full-time. I don't really do the heavy lifting, but I still do the odd job here and there. And recently, I've been in charge of all the balloon flights. Balloon director, flight manager, whatever it is. I've been sending stuff to space on a budget. What we do is we get a massive weather balloon, strap it to whatever we need to send up, and it just goes up. It's cheap, it's a better way to get into space than rockets, and I'm just going to give you a little introduction on what I did last year. So, I already went over what it is. We call it a HAB, high altitude balloon. Cheap, readily available materials, and you can attach a bunch of cameras on, so you can see what the edge of space looks like from Earth. What we did last year was we got a model of Bino 234, stripped off a few of the solar panels and the top, and just put some other stuff on, like a GoPro and a 360 camera. That thing on the rod at the end. This is what it looks like when it's stowed, just after we cut the rope, just up before it went up.
What does stowed mean?
Stowed means everything is put into place and tied down. So in our case, we had solar panels and an antenna, which spring into action a few seconds after launch. Sorry, 30 minutes after launch. This is better for storage. Fits within the place in the ISS and helps things go smoothly. After a few minutes, we deployed the panel. This wasn't really meant to recharge it at all, just to really show that it could be deployed. I don't know if anyone's told you this before, but our panels deploy via burn wire. We tie it down with a string, we burn it with a resistor, and then it springs out. Kyle might be able to tell you how it stays in place though. So, our primary objective was to test out comms. Bino 234 communicates primarily through UHF radio, that's ultra high frequency. Similar to the stuff you get through radio stations, but on a stronger power. On a band of radio that no one really uses but space communication. We had a GPS, which told us coordinates throughout the duration of the flight. And we had a backup system of comms, Iridium, stuff that Elon Musk uses. So that's a good backup when the balloon landed. Help us find it on the ground. Our secondary objectives was to test the deployable panel, like I said, see if the batteries recharge, and take photos of Earth. Seriously, if I had the 360 camera now, I'd probably show you a good picture of what it looked like, because when you get up there, you see the curvature, you see the city, you see everything below you, and it's just something you can't replicate, can't simulate. And that's basically what I feel is the main reason why we do this, just to show where we're going. We also had some last-minute objectives that turned out to be very helpful. Chief among them being a radar reflector, that metal thing in the corner. So basically, weather stations use radar to see clouds, to see if there's any rain coming along. You can build something out of cardboard and aluminum tape, which does a similar thing. We also had a LTE-enabled tracker. It's a lot of jargon, but it's basically a little magnetic bike tracker that you put into your car or bike, and if it gets stolen, you'll find it on your app. Same idea for the satellite here. And finally, we wanted to transmit battery voltages via UHF. So if we couldn't get the GPS to work, at least we'd have something going by our main antenna. So this is what the flight path looked like. It took 2.5 hours, reached an altitude of 30 kilometers, and landed about 185 kilometers away from the start point. Went to York, don't know if anyone's been there, it's got some pretty cool bakeries, but it's just far east in the hills. It was a good launch and landing site because there's a very rural population in the surrounding area. So if it fell prematurely, it wouldn't have hit anyone. And when it did fall, it wasn't in anyone's way. And here's a little clip of what launch looked like.
9, 8, 7, 6, 5, 4,
So yeah, bit of force in that one. Lesson learned, don't let go by the top. Always let go by the bottom. So what's cool about it is, you guys might have noticed it's a bit cloudy. That made it pretty hard to track things. Also, clouds are like, I don't know, 100% water, so things got fried very quickly. Case in point, we lost the balloon. Wait. So, we did get some results. Failure is good. I mean, not ideal, but you do learn something from it. And we learned within the first 10 minutes that we could get data. So our antenna worked. Great, big tick. Primary objective achieved.
So what transmissions did you get in the 10 minutes?
We got the acceleration, so when things slingshotted, we got a notice that it did in fact slingshot, And we also got a bit of telemetry for battery voltages. Batteries are discharging, things were active. That's good. Space and Earth are different environments, so yeah, what you might prepare on the ground to make your satellite might not be ready for space. And there might be things you won't notice until you get up there that you need to fix and prepare. So that's also a good thing. And finally, tracking is important. You can put 4 layers of tracking, but they all might fail. It's good to find something that works on the ground and works in an environment like space or in a cloud. And, well, we didn't do enough testing beforehand. So what we're doing for next time is that we're using the HAB process to really push our creativity in the team. We've all come up with ways to go around boundaries, restrictions that other people have applied for making the HAB not as easy as it should be. But that's good. Everyone has a good time coming up with ideas and being a part of this. We've also really developed a solid approval and design method for the HAB. So if we want to do this again, it's not going to take a whole year. It'll just take a few months. And finally, we proved potential for future testing. So we did 90% of the heavy lifting. We got to the launch site, we cut the rope, we sent it up. We just need to do that again and this time recover it. So it's going to be used for other payloads. Now other companies want to give it a go. Other high schools want to put their own payloads on board. And that's a tick in my book. So yeah, what's next? Well, we were going to search around a predicted landing site, which is right in the middle of nowhere, halfway between here and Kalgoorlie. But it didn't come into fruition because it took a lot of time, too many variables, didn't have a budget for it. That's fine, lesson learned. If anyone's in that area and finds a 360 camera, we're launching a payload from another aerospace company. Aerospace, we're setting up a camera.
Can I swap you? Sorry, my ran out of batteries.
No worries.
You can just leave the other one.
Okay. Yes, another company is launching a camera which is going to point downwards towards Earth. So they'll be able to see everything get smaller as it goes up. We're also launching a couple of small cameras, not 360, but still light enough to do a good job. And we might have a high school putting their payload on board, a little camera setup.
Yeah, so John Curtin College of the Arts in Fremantle is hopefully going to have a little camera and a Raspberry Pi and a battery fly on the balloon. So if you guys are involved in the normal school term BINAX program with your school, so it's like Balcata, you might have some opportunities to apply some stuff like that in the future. And if you're not, then figure it out as well if you're from a different school.
Could be you very soon.
Yeah. Any questions from the actual students instead of me, my Dorothy Dixes? Was there a question over here? Did you have one?
Yeah. What did
Yeah.
you film the balloon with? Was it just helium?
Yeah, we literally went out to a party supply store, just said, hey, we're launching a massive balloon, but can we have a tank that fills 700 instead? And they're like, yeah, sure, no worries. Helium's expensive. Fun fact, it's running out, like we're running out of helium, so prices have gone up. Yes?
What's the difference between a high altitude balloon and a normal balloon?
Right, well, a high altitude balloon is built to, one, take a lot more helium than like your average party balloon, and two, withstand enough temperature and pressure differences to reach the high altitudes. I think it's made of the same material, it's all latex, but it's a bit more pricey, so there's that as well. Right, so if that's all good, I'll have a hand back to Meg or give a presentation about debugging, whatever is
I did it.
better.
Thank you, Charlie. We're going to go into debugging now.
Sure.
Thanks, Charlie. Oh, have you got a presentation for debugging?
I do.
Oh, cool.
All right, I'm gonna skip the introduction because if you've got me already, why? Anyway, debugging. Best part of anyone's engineering experience. So, I know you guys are doing electronics and coding. life and coding is like 1% actually writing and 99% just working out what's wrong. This guy gets it. Great. Same goes for electronic design, but with more dire consequences. If you wire something in the wrong way, it can explode, it can catch on fire. I've done that way too many times. It's a bit of a safety risk. If you see Daniel Bashan, don't tell him I did that. And finally, if it's working right immediately, you guys probably did something wrong or you copied from someone. So shame on you. But that probably won't happen, so don't worry about it. So fun fact, debugging has been around for a while, around Nikola Tesla and Thomas Edison's time, but this is a picture of the first computer bug. This lady, Grace Hopper, was working at Harvard, one of the first computers ever made. It had all these spinny dials. She found a moth frightened the electronics, and that stopped the computer from working. So she took it out, taped it into her notebook and said, hey, look, it's a real computer bug. So yeah, if you guys play your cards right, same might happen to you today.
What year was this?
Oh, like early 1947, I think?
Oh, cool.
Yeah, ages ago. Back for actually.
Computers were the size of entire rooms, so bugs were able to get into them.
Yeah, actually now that you mention that, it does make more sense.
And the importance of keeping an engineering notebook.
Yeah.
Yeah.
Could be
Some of the tweet bugs.
forged in the pages history.
So debugging, if I haven't made it clear, it's just problem solving. It's just going through what you've done, looking at what went wrong, and fixing it. Simple stuff. Take a step back and approach it step by step. Like everything with life, it's better if you take it, break it down, and do the small things first. So, bit of advice for software. Read your errors. I know at least one of you has learned C in programming, so you're in favor already. This is what a C program looks like, and this is just a basic error which has happened in the compiler. When you run it, your computer will tell you something's wrong, go back through it and have a look at what's wrong. And if that doesn't work, check your models and see if they match your diagrams for electronics. It's basic resistor and LED setup. Just make sure everything's plugged in where they should be. No worries. Easy stuff, very basic. But you'd be surprised how many people forget that. I'm guilty of it. Check your specific code blocks. I don't know what your programming looks like, but if there's something wrong in one section of the code, that doesn't mean your entire code is wrong. Just go back and see what's wrong. This is an example of logging. So this is me going back into the code. I've literally told my computer to print out a message to see if a certain code is run. And when I've executed it, it's printed out that message. Function has executed, great. So this is a really good way to see what you've done with debugging. Just go back, print stuff out, tells you if something's working or not. And finally, if you can't work out what's wrong, just ask your favorite web browser. Go online, search, hey, I've got this issue, copy and paste those terminal messages, those error messages. Chances are someone's had the exact same problem as you. Like even today, if that's an issue, just go online, look it up. It's like 99% of coding. Even our top programmers on our team do the same thing. So yeah, that's basically it. I'll probably help you around today, and let's get to it.